It is 9:45 at night. You are not hungry. You ate dinner 2 hours ago. You are sitting on the couch, minding your own business, and then something happens that you have probably experienced hundreds of times without ever understanding why. A thought appears, not a subtle suggestion, a command, something sweet, something specific, chocolate, ice cream, biscuits, whatever your particular weakness is, it arrives with an urgency that feels almost physical. You resist for a few minutes, maybe 20, and then you are standing in your kitchen at 10 o'clock, eating something you did not plan to eat, feeling vaguely disgusted with yourself for the lack of discipline you seem to have every single night at the same time. Here is what nobody has ever told you about that moment. Your willpower did not fail. Your brain executed a program, a precisely timed, hormonally driven, evolutionarily ancient program that activates in the evening in response to specific neurochemical conditions, and it was designed to be nearly impossible to override through conscious effort alone. Because the part of your brain running this program is not the part that makes conscious decisions. It is the part that kept your ancestors alive when food was scarce and survival depended on consuming calories whenever they were available. Tonight, the same program is running in your modern brain, in your modern kitchen, surrounded by more food than any human in history has ever had access to. Understanding the exact mechanism does not just explain the craving, it gives you the only tools that actually work to address it. To understand why the craving hits at night specifically, you need to understand the daily rhythm of the two hormones that govern your appetite more than any others: leptin and ghrelin. These two molecules run on opposing circadian rhythms that are precisely timed by your biological clock. Leptin is produced by your fat cells and travels to your hypothalamus, where it suppresses appetite and signals that energy reserves are adequate. Ghrelin is produced primarily by your stomach and travels to your hypothalamus, where it stimulates hunger and drives food-seeking behavior. In a metabolically healthy person with a well-regulated circadian rhythm, leptin rises through the day, reaches its peak in the late evening, and keeps appetite suppressed through the night. Ghrelin does the opposite. It rises before meals and drops after eating. This elegant system was designed to keep you fed during daylight hours and satiated through the dark hours, when for most of human history, food was unavailable and hunting was dangerous. But here is what chronic sleep deprivation, irregular eating timing, and constant artificial light exposure do to this system. They invert it. Studies from the University of Chicago showed that just 2 nights of restricted sleep, sleeping 4 to 5 hours instead of 8, reduced leptin by 18% and increased ghrelin by 28% simultaneously. The hunger signal goes up, the satiety signal goes down, and both of these changes are most pronounced in the evening, precisely when your environment is offering you the most tempting food options and your executive function is at its daily low point. They are the hormonal consequence of a sleep-disrupted, circadian-disrupted nervous system trying to compensate for a perceived energy deficit that does not actually exist. But hormones are only the foundation. The mechanism goes deeper. Your brain's reward system, the mesolimbic dopamine pathway that runs from the ventral tegmental area through the nucleus accumbens, follows its own circadian rhythm that is almost entirely separate from your hunger hormones. Dopamine, the neurotransmitter of anticipation and reward, naturally declines in the evening as your brain prepares for sleep. This decline is part of the normal wind-down sequence, but it creates a specific neurological vulnerability. When dopamine is low, your brain becomes more sensitive to dopaminergic stimuli. It is not looking for less reward. It is desperately looking for more. And nothing triggers a faster, larger dopamine release in your reward system than sugar. Specifically, the combination of sugar and fat, the exact macronutrient combination present in virtually every processed food engineered for palatability. Ice cream, chocolate, biscuits, cake, These foods produce dopamine responses in the nucleus accumbens that are neurologically comparable to addictive drugs in their speed and magnitude. Your brain is not craving these foods because you are weak. It is craving them because in the evening, with dopamine naturally depleted, your reward system is in a state of neurological hunger that is completely independent of whether your stomach is full or empty. The sensation you experience as a craving for sugar is not coming from your digestive system. It is coming from the reward circuitry of your brain, seeking the fastest available route back to dopamine sufficiency. There is a third mechanism that most people have never heard of, and it may be the most powerful of all. It involves the relationship between cortisol, serotonin, and carbohydrate consumption. Your cortisol follows a precise daily curve, high in the morning, gradually declining through the day, reaching its lowest point around midnight. In a healthy stress response, this decline is smooth and predictable. But in people who are chronically stressed, emotionally exhausted, or carrying significant psychological load from their work and relationships, which describes the majority of people in modern life, cortisol does not decline smoothly in the evening. It stays elevated, or it drops and then rebounds. Chronically elevated evening cortisol does two things that are directly relevant to your sugar cravings. First, it suppresses serotonin synthesis by competing for the same enzymatic pathways. Serotonin is the neurotransmitter most associated with calm, contentment, and emotional stability. When your serotonin is low in the evening, as it reliably is after a long, stressful day, your brain registers this as a form of psychological discomfort that it urgently wants to resolve. Second, elevated cortisol raises your blood glucose through gluconeogenesis and then drives a compensatory insulin response, creating a mild blood sugar dysregulation that the brain interprets as an energy deficit. Your brain has learned through years of repetition that eating carbohydrates, particularly sugar and starch, produces a rapid but temporary increase in serotonin through insulin-driven tryptophan uptake across the blood-brain barrier. Eating sugar at night is at the neurochemical level a form of self-medication. Your brain is using food as a serotonin delivery mechanism, and it works, briefly, which is exactly why the habit is so difficult to break through willpower alone. You are not fighting a preference. You are fighting a neurochemical feedback loop that your brain has been reinforcing every evening for years. A fourth mechanism is the one that closes the trap. Your prefrontal cortex, the region responsible for impulse control, delayed gratification, and the ability to override urges with rational decision-making, is the most metabolically expensive region of your brain. It requires a continuous and substantial supply of glucose to maintain its executive functions. Through the course of a demanding day, the prefrontal cortex depletes its functional capacity through a process researchers call ego depletion or decision fatigue. By 9 or 10 o'clock at night, after hours of decisions, emotional regulation, concentration, and social navigation, your prefrontal cortex is running on reserve capacity. Its ability to evaluate the long-term consequences of your choices and override the short-term signals coming from your reward system is significantly diminished compared to its capacity in the morning. It is a documented neurological phenomenon with measurable correlates in prefrontal cortex blood flow and executive function testing. The same person who makes disciplined food choices all morning and afternoon is neurologically a different person at 10 o'clock at night. The impulse control system that kept them disciplined all day has been depleted. The reward system that wants sugar has not. The outcome is almost predetermined by the time the craving arrives. Here is what all of this means practically. Addressing night cravings through willpower alone is the equivalent of trying to paddle upstream in a river with no paddle. The current is running against you through 4 separate biological mechanisms simultaneously: hormone dysregulation, dopamine depletion, cortisol-driven serotonin suppression, and prefrontal exhaustion. The people who successfully eliminate night cravings are not the ones with more discipline. They are the ones who address the upstream conditions that create the craving in the first place. Sleep is the most powerful single intervention because it simultaneously restores lectin signaling, normalizes ghrelin rhythm, replenishes dopamine baseline, and allows cortisol to complete its natural decline. 7 to 8 hours of consistent sleep, maintained at the same time every night, produces measurable reductions in evening craving intensity within 2 weeks. Not because your willpower improved, but because the neurochemical conditions that generated the craving are no longer present to the same degree. Protein at dinner is the second most powerful lever. Protein consumed in the evening raises evening tryptophan availability, directly supporting serotonin synthesis and reducing the neurochemical deficit that drives the self-medicating carbohydrate response. A dinner that is high in protein and low in refined carbs keeps blood glucose stable through the evening, eliminating the cortisol-driven compensatory response that contributes to cravings in the first place. The third intervention is light management. Bright blue spectrum light in the evening suppresses melatonin, disrupts the leptin-ghrelin rhythm, and keeps your reward system in a state of heightened activation. Dimming your environment after sunset, eliminating screens or using blue light filters, and lowering the overall light intensity in your home allows your circadian hormonal system to begin its natural wind-down sequence, reducing the neurological vulnerability that the craving exploits. Your night cravings are not a character flaw. They are a mechanistic consequence of 4 biological systems simultaneously pushing in the same direction at the same time every night, because your daily patterns created the conditions for them to do so. The evening environment that most modern people inhabit, blue light until midnight, chronic stress, inadequate sleep, meals that destabilize blood glucose, is essentially a perfect laboratory for manufacturing night cravings from scratch. Remove those conditions systematically, and the craving diminishes. Not because you became stronger, but because you stopped building the neurochemical environment that made the craving inevitable. Your brain was not betraying you every night. It was responding perfectly to the conditions you gave it. Change the conditions, and the response changes with them. If this changed how you understand your own cravings, subscribe to this channel. Every video here goes inside the exact mechanisms, so you stop blaming yourself for biological processes and start understanding how to actually change them. Like this video and share it with someone who beats themselves up every night for reaching for sugar. Show them it was never about willpower.